Hi viewers, so welcome back to the channel. So in the previous video we have discussed till problem number 4. So in this video we are going to continue the conversion of solids. So the main important thing that we need to remember here is nothing but, so what we need to remember, so whenever you are having conversion of solids, volumes remain constant. So using that simple concept we are going to solve each and every problem of this. Right, now going to question number 5. A container shaped right circular cylinder having diameter 12 centimeters and height 15 centimeters is full of ice cream. Right, so similar type of question we have done in the previous videos. So here one more question is given. The ice cream is to be filled into cones of height 12 centimeters and diameter 6 centimeters having hemispherical shape on the top. Right, so from this what you can understand, so the given ice cream is present in a cylindrical vessel, right, so which is having radius 6 centimeters and height 15 centimeters. So this particular ice cream has to be filled in so cones, so which are in the shape of a cone and a hemisphere on its top. So how many such cones are formed? So how many such cones are formed is nothing but given by, so here this particular cylinder is not converted into a single shape, that's why we cannot directly take this is equal to this particular shape. So that's why what I am doing is I am going to fill into some certain n number of cones. So I am going to multiply this particular volume with n, right. So from this what I can say, so volume of cylinder is equal to n into volume of combined solid. So this is nothing but combined solid. So from this what I can say, so volume of cylinder, so already we know the formula. Volume of combined solid means, so we need to take volume of cone and hemisphere, right. So from this we are going to write down the details. So height of the cone is 12. So first of all we are going to fill the details of cylinder. So what are the things that are given for cylinder? So cylinder is having radius is equal to 6 centimeters because diameter is 12 centimeters, so radius is 6 centimeters. So height of cylinder is 15 centimeters. Next, moving on to the combination of solids. So here radius of hemisphere is equal to radius of the cone. So radius of cone is equal to radius of hemisphere. So which is nothing but how much? So here diameter is given, right? So diameter is 6, so automatically radius is 3 centimeters. Next, height of cone. So height of cone is 12 centimeters. Now substituting these values inside this formula. So volume of cylinder, so pi r square h is equal to n into volume of combined solid. So combined solid is nothing but 1/3 pi r square h plus 2/3 pi r cube. Now from this I can directly cancel this value of pi. Now substituting the values of r. So here r is nothing but radius of cylinder, height of cylinder. So here this is nothing but height of cone, and radius of cone and hemisphere both are same, right. So radius of cylinder is given by 6 into 6 into height of cylinder is 15 is equal to n into radius of cone is 3 into 3 into height of cone is 12 plus, so this is all under one bracket. So 3 into 3 into 12 plus, so this is 2 by 3 into what is radius here, 3 into 3 into 3. So 1 3 gets cancelled. Now here what I am going to get, so don't cancel anything, so simply write it down. So 6 into 6 into 15. So since I need n, so I can directly transpose everything to the other side. So this becomes divided by, so 3 into 3 9, so 12 nines are, so 12 nines 108 plus 3 3 is 9, 9 2s are 18, which is equal to n, right. Now so instead of all these things, so instead of multiplying this, so what I can do, so I can take 9 as common, no. So here 3 3s are 9, here also 3 3s are 9. So if I take common, so here I will be left with 12 plus 2. Now so 12 plus 2 is 14, right. So this 9, it goes 3 times, this goes 2 times. Next, this 3 in 15, it goes 5 times. Next, this 2 in 14, it goes 7 times. So from this, what I am going to get? So is there any mistake that we have done here? So pi r square h, so 6 into height of cylinder is 15. So 6 into 15 is equal to n into, sorry, here 1 by 3 we have missed, right? Okay, so here we have missed 1 by 3. So while doing calculations, so these are nothing but the simple mistakes that we usually do, right? So n into, here 1 by 3 is there, so 1 by 3 into radius is 3 into what is height of cone? So height of cone is 12, plus here it is 2 by 3 into 3 into 3 into 3. So here 3 gets cancelled, here 1 3 and 3 gets cancelled, right? Now from this, how can I write this as 6 into 15 divided by, here from this what I can take common, 3 is 9, so 9 2 is 18, right? So here, so from this n is equal to, here 12 3s are 36, plus, so 3 3s 9, 9 2s are 18. So 36 plus 18, how much? So it is, I think, 54, right? So 6 into 15 by 36 plus 18 is 54 is equal to n. So 6 in 54, 6 9s are 54. Again, this goes 2 times and this goes 3 times. Again, this 5 times. So what I am left with, 5 2s 10. So n is equal to 10. So from this, what I can say, n is equal to 10 ice creams. So how many ice creams I can fill? So I can fill n is equal to 10 ice creams, right? So totally I can fill 10 ice creams by using the ice cream that is present in the cylinder, right? Next, moving on to one more question. See here, so there are, so how many silver coins? So there are silver coins which is having diameter 1.75 centimeters and thickness 2 millimeters. So here one is given in centimeters and the other is given in millimeters, right? So needed to be melted to form a cuboid of dimensions 5.5 into 10 into 3.5 centimeters, right? So there are coins. So how will be the shape of a coin? So a coin will be in the shape of a cylinder, right? So coin will be in the shape of a cylinder which is having less amount of height. So this particular n coins are to be melted and we need to form a cuboid. So we need to form a cuboid, right? So this is the question, right? Now what I can say, n into volume of each coin is equal to volume of cuboid. Now from this, first of all we need to write down whatever the things that are given, right? So volume of coin is nothing but volume of cylinder. So volume of coin is nothing but volume of cylinder. Okay, so first we are going to talk about the values of cylinder. So what is given? So diameter of cylinder is given. So what is diameter of cylinder? So 1.75 centimeters. So this 1.75 centimeters I can write it as 175 by 100 centimeters. So from this I can obtain the radius of this, so which I can write it as 175 by 200 centimeters because I need to divide with 2. Next, height or thickness. So height of cylinder is 2 millimeters. So 2 millimeters means 2 into 10 power minus 1 centimeter, right? Because 1 centimeter is equal to, so 1 centimeter is equal to how many millimeters? So 10 millimeters, right? So 2 into 10 power minus 1 centimeters. Okay, from this what I got? So 2 into 10 power minus 1 centimeters. So which I can write it as 2 by 10 centimeters. Okay, so 1 millimeter is equal to 10 power minus 1 centimeters. So which can I write as 2 by 10 centimeters. So this is about cylinder. Next, coming to cuboid. So cuboid, I can directly write length is 5.5. 5.5 means 55 by 10 I can write. Next, breadth is 10 centimeters. This is 3.5 means I can write it as 35 by 10. Right? Now from this, n is equal to what I can write? So volume of cuboid divided by volume of cylinder. Volume of cuboid divided by volume of cylinder. So directly when I write the values, so pi r square h by, so sorry, volume of cylinder is LBH, no? So L into B into H by pi r square h. So this is about cylinder. Now when I substitute the values, what is length? So length is, I can write as 55 by 10 into what is breadth? So I can write as 10 by 1 into what is height? So I can write as 35 by 10 divided by, so pi I can write it as 22 by 7. So I can write it as 22 by 7 into what is radius here? So radius is 175 by 200. So 175 by 200 into 175 by 200 into what is height? So height is nothing but 2 by 10. Now when I simplify these values, so how to do simplification? So see the simplifications. So 25 table, so 25 8s are 25 7s are 25 7s are 25 8s are. So here we are getting 7 by 8. Next, one more. So in the numerator, so I can cancel this 10 and 10. Next, this 10 goes 2 times, this 35 goes 7 times, right? Next, this numerator 22 goes 2 times, this numerator 5 goes 5, so 55 goes 5 times in 11 table. Next, any more cancellations that are possible? So here 2 2s are 4, so this goes 2 times. Next, this 2 in the denominator, this 2 in the denominator I can cancel out. And what are the things that are left? So here 7 in the numerator, this 7 in the numerator I can cancel out. Next, what are the things that are left here? So here I am having, so in the numerator I am having 5, so 5 by 1 into, so these all are the things that are present in the denominator. So 7 by 8 tens are 80, so it becomes 80 by 10. So 80 by, sorry, it is 80 by 7, right? So here one more 7 is there, no? So this 7 I can cancel out. So this 7 also will go. So I am going to get 5 into 80. 8 5s are how much? 40. So followed by 1 0. So totally how many coins do I require? So I require totally 400 coins. So if I melt 400 silver coins, then I am going to get a cuboid of that particular size, right? Next, moving on to one more question. So question number 7. So what is question number 7? A vessel is in the form of inverted cone. So inverted cone means, so usually what we have done till now, we have taken cone with base as circle. Now we have inverted this cone. So this cone is filled with water up to the brim. So up to the rim water is poured, and what he is doing, so when lead shots, each of which is sphere of radius 0.5 centimeters dropped into the vessel. So there are some spheres, so these are dropped into the vessel. So when the spheres are dropped into the vessel, what will happen? Water will spill out, no? So he has given that 1/4 of the water is spilled out. 1/4 of the water is spilled out, and he is asking you to find the number of lead shots dropped. Number of lead shots dropped. So understood the question? So here there is a inverted cone in which water is filled up to the rim, and it is having height of 8 centimeters and radius is 5 centimeters. And after that what happened? So some lead shots are dropped which are in the shape of a sphere having radius 0.5 centimeters. Then what happened? 1/4 of the water flowed out. So find the number of lead shots dropped into the vessel. So is asking you to find out the number of lead shots. So already we know that number of lead shots, so n into volume of each lead shot is equal to, so this particular volume, so how much water has been come out of it? So 1/4 of water, no? So this 1/4 of water which is spilled out is nothing but equal to the volume of this sphere only, no? Because of these spheres we have water that is come out. So that means this n into volume of sphere is nothing but equal to 1/4 of volume of cone. So n into volume of sphere is equal to 1/4 of volume of cone. So from this, n into volume of sphere is nothing but 4/3 pi r cube is equal to 1/4 into volume of cone is nothing but given by 1/3 pi r square h. It is given by 1/3 pi r square h. So on both sides I can cancel out pi and pi. So this height is nothing but height of cone, and this is radius of cone, and this is radius of spheres, right? So from this I can cancel out 3 and 3 in the denominators. Now from this, when I substitute the values, n into 4 into what is radius of sphere? So here radius of sphere is given now 0.5 centimeters. So radius of sphere is 0.5 centimeters. So 0.5 means 1/2. So this I can write as 1/2 whole cube is equal to 1/4 into what is radius of cone? So radius of cone is given as 5 centimeters, no? So this is nothing but 5 into 5 into height of cone. So height of cone is given as 8 centimeters. So this 4 in 8, it goes 2 times. Now from this, n into 4 into 1/2 whole cube is nothing but 1/8. Again this 4 in 8, it goes 2 times, which is equal to 5 5s 25 into 2. Now when I transpose this 2 onto the other side, so already this is 25 into 2. So this 25 into 2 I can write it as 50. So from this, if I transpose this 2, it becomes 50 into 2. So which gives me 100. So what is n here? So these are nothing but the lead shots. So if I draw 100 lead shots into this vessel, so then 1/4 of the water flows out. So for whole water to get flowed out, then we need to use 400 lead shots. So this is one more question that we can develop from this question, right? So to get 1/4 of the water to get flow out of this vessel, so we need to drop 100 lead shots. Okay, so from this the answer is 100 lead shots. Okay, next moving on to one more question. See, a solid metallic sphere which is having diameter 28 meters is melted and recast into number of smaller cones which are having diameter and height is given as 3 centimeters. So is asking find the number of cones. So from this what I can say? So there is a sphere. This is being melted and casted into n smaller cones. So this particular sphere is converted into n smaller cones. So from this what we can say? Volume of sphere is equal to n into volume of cones. So from this we can directly find out the value of n, right? So writing down the values of sphere first. So for sphere, what are the things that are given? So diameter is given. So from that, radius of sphere is given as, directly I can write as 14 centimeters. Next, he has given diameter of cone, no? Right? So for cone, what are the things that are given? So diameter of cone is given as, so 4 2s are 8, 8 plus 2. So it is given as 10/3 centimeters. Sorry, 10/3 or 14/3. So it is given as 14/3 because 4 3 is 12, 12 plus 2, 14/3. So clearly radius of cone is given by 7/3 centimeters because we need to divide with 2, right? Now from the figure, so from the question we have drawn the figure. So from the figure what we can say? So volume of spheres is equal to n into volume of each cone. So from this, what are the things that we are going to get? What is the formula of sphere? 4/3 pi r cube. So this is nothing but about sphere is equal to n into 1/3 pi r square h. So these are nothing but related to cones. So from this, by 3 get cancelled, pi gets cancelled. Now whatever the things that are remained, so substitute those values. So what I am going to get here, so which gives me, so 4 into what is the radius of sphere, it is given as 14 centimeters, no? So it is 14 into 14 into 14 is equal to n into, so here radius of cone, so what is radius of cone? 7 by 3. So I can write as 7 by 3 into 7 by 3 into height of cone. So what is height of cone given? So height of cone is given as 3, no? So h suffix c is equal to 3 centimeters. So if I substitute here, so this becomes 3 by 1. So from this 3 3 gets cancelled. Now next, so this 7 and 7, 2 7s are here, so this I can cancel 2 times, this 14 I can cancel 2 times, right? Now finally what I am left with, so n is equal to 4 2s are 8, 8 2s are 16, so 16 into 14 into 3, so 16 3s are 48, so 48 14s, so I need to find out 8 4s are 32, so 3 is remained, 4 4 16, so this becomes 19, and next what I am going to get, 48, so 2 9 plus 8 17, so 4 plus 1 5 plus 1 6, so totally how many cones I am going to get? I am going to get 672 cones. So the answer is 672. So these many number of cones, so we are going to obtain, so when we are converting a solid metallic sphere into cones, right? So this is about question number 8 of this particular concept, right? Let us move on to one more question. See here, a cone is having height 24 centimeters and radius 6 centimeters, so which is made up of modeling clay. So modeling clay means the children used to play with this clay, right? So it is nature friendly. So using this clay, so he is having a cone. The child reshapes it into the form of a sphere, right? So this particular cone, so whatever the cone that is present, so this cone he has converted into the shape of a sphere, right? So here direct conversion is done from one shape to the other shape. So directly what we can say from this, volume of cone is equal to volume of sphere. So volume of cone is equal to volume of sphere, because volumes remain same if their shapes are also shapes are changed. So volume remains constant, right? So what is volume of cone? Volume of cone is 1/3 pi r square h is equal to volume of sphere is nothing but 4/3 pi r cube. So here on both sides I can cancel this pi. This is radius of cone, height of cone, this is radius of sphere, and on both sides I can cancel 3's in the denominator also. Now substituting the values, what is radius of cone? So radius of cone is given as 6, so 6 into height of cone is given as 24, which is equal to 4 into, since I need to find radius of sphere, this is rs whole cube. So here this 4 cancel this 24, how many times? 6 times. So on left hand side we are having 6 cube is equal to rs cube, so which implies this r suffix s is equal to 6 centimeters. So clearly what is the radius of sphere? So radius of sphere is 6 centimeters. Now let us move on to one more question. So what is given here? The diameter of internal and external surface of hollow hemispherical shell. So hollow hemispherical shell means how will be the shell? So you will have, so this particular shape, so this will have internal radius as well as external radius, right? So 6 centimeters and 10 centimeters are diameters of internal and external surfaces. It is melted and recast into a solid cylinder, right? So this we are recasting it into a solid cylinder. That means shape to shape conversion. If there is shape to shape conversion, then what we can say? Volumes remains constant. So from this, volume of hollow cylinder is equal to, volume of hollow sphere. So it is hollow sphere, no? So volume of hollow, is it sphere? So since it is a sphere, so we need to consider spherical shape, right? So this spherical shape is hollow in shape, So the only thing that we have is, so this is capital R, and since the material is present only outside, so inside it is hollow, so that's why we are going to have small r. So we are going to have two types of radii, one is external radii and the other one is internal radii. So here we are given with hollow hemispherical, right? Sorry, hemispherical means, so you will have hemisphere. So the before figure is correct. Okay, so from center this is small r, so from center to the external radius it is capital R. So it is hemispherical shape, so hollow hemisphere. So volume of hollow hemisphere is equal to volume of solid cylinder. So what is the formula of volume of hollow hemisphere? So we know volume of hemisphere, it is nothing but 2/3 pi r cube, right, is equal to volume of cylinder pi r square h. See, so whenever you are given with hollow, so simply in the place of r, simply replace with the capital R and small r and give their individual powers. So 2/3 pi capital R cube minus small r cube. So this is nothing but the formula. So that is the reason why I have written volume of hemisphere first. So 2/3 pi r cube is nothing but volume of hemisphere. So in the place of r, if I replace with the capital and small r with their respective powers, then we are going to get volume of hollow hemisphere, right? On both sides I can cancel out pi and pi. So from this 2/3 into what is capital R? So here outer diameter is given, not radius is given, diameter is given. So diameter is given as 10, so its half is 5, so this gives me 5 cube minus small r is, so small diameter is 6, so its half is 3 cube, is equal to what is the radius of cylinder? So radius of cylinder, but here diameter of cylinder is given, so which is nothing but 14, so its half is 7, so 7 into, since I need to find out the height of the cylinder, so height is h. Now this is nothing but 2/3 into 5 cube is 125, 3 cube is 27, so this gives me 98 is equal to 7 into h. So 7 7s are 49, so this 49 can be cancelled 2 times. So from this height of the cylinder is nothing but given by 4/3 centimeters. So the height of the cylinder is 4/3 centimeters. Okay, so likewise we can find out the height of the particular hollow cylinder, right? So what is the answer? So he is asking about height of the cylinder, right? So height of the cylinder is nothing but 4/3 centimeters, right? So the remaining problems, so we are going to discuss in the next video. So thank you for watching.